This is the third and final video in a series of 3 presenting the paper Intelligent Transportation Systems, a survey on modern hardware devices for the era of machine learning. The authors of this article include members from the Intelligent Hardware Research Group at BAU in collaboration with Professor Hussein Mouftah, the Canada Research Chair in Optical Networks and Distinguished Professor at the School of Electrical Engineering and Computer Science at the University of Ottawa. The previously presented cross-matching evaluation chart aimed at ranking machine learning techniques and modern hardware devices that promise a certain level of performance per ITS complexity. In addition, a conceptual selection model was proposed with the purpose of recommending the machine learning technique and hardware device suitable for a certain ITS application. The machine learning selection submodel would take in the machine learning complexity and competency ranks, as well as some selection indicators such as the type of the problem, whether being supervised, unsupervised, or reinforcement learning based, and its operational scenario to recommend a suitable machine learning technique. Similarly, the determined hardware device competency, as well as some selection indicators such as budget, processor, and IC technologies, will serve as input to the hardware selection submodel for it to recommend a good enough hardware device. These selection submodels can be formulated using traditional decision-making techniques based on multiple criteria as combined statistically, or using machine learning. To assess the performance of the proposed framework, a validation procedure was followed in which the author's choices in the surveyed articles were reasoned about for machine learning and hardware competencies with those obtained using the cross-matching evaluation chart previously presented. The selected references followed a certain criteria to be chosen where they covered all types of hardware devices, machine learning techniques, and ITS applications as per the proposed taxonomy previously presented. They provided enough information to assess the complexity and competency of the ITS applications, machine learning techniques, and modern hardware devices used. And finally, redundancy was eliminated by considering each member of the taxonomy only twice. The outcome of this validation was illustrated as radar charts, which present the classification outcome based on the author's choices and the proposed cross-matching evaluation chart for machine learning and hardware competency. The difference between the author's choices and the result of the cross-matching evaluation chart was quantified in terms of the difference in classification metric, or delta C. This metric is the absolute difference in scale levels, which could be either nil, small, or significant. The results show that 62.5% of the references have a nil delta C, 25% have a small delta C, and only 12.5% have a significant delta C. This shows that most implicit evaluations done by the authors of these papers are in conformity with the proposed evaluation model. The common practices that were observed in the literature were also identified, such as the abundant use of convolutional neural networks. The following table was presented, which shows the investigations that attained the highest accuracy with a variety of ITS applications, such as traffic detection and road detection. Lastly, despite the significant progress in the literature, there exist several gaps and limitations in the investigated work which were identified by the authors. Pointers to future work were also presented, since the surveyed literature also presents opportunities for modifying and extending the usage of the current approaches. These future directions present numerous opportunities for researchers to tackle hardware challenges for machine learning implementations within the scope of intelligent transportation systems while considering the evaluation framework developed in this work. This has been the third and final video presenting the paper Intelligent Transportation Systems, a survey on modern hardware devices for the era of machine learning. The links to the previous videos will be in the description section below.